Good morning, everyone. My name is Nikhil, and this is my final presentation for data intelligence. The business problem that I'm trying to solve is determine whether the presence of speed cameras reduces the frequency of car crashes. To help me with this investigation, I am working with 5 datasets that I got from the chicago.gov website, so they are publicly available. In my code, I'm performing a whole lot of data wrangling as well as exploratory data analysis to establish experimental groups. First one being treatment, which contains data on crashes recorded within 250 meters of speed cameras. Conversely, there's the control group, which contains data on crashes recorded outside of 250 meters of the speed cameras. As such, my null hypothesis is pretty straightforward. It states that the crash rate for treatment and control groups are the same, with my alternative hypothesis stating that the crash rate for the treatment group and the control groups are different. Since I'm not too concerned with the direction in which the differences lie, I'm performing a statistical two-tailed t-test. The outcomes will be a BI report outlining the various crash statistics that I come up with, as well as a regression model, which will help viewers understand how individual factors contribute to the crash rates. Coming out of this, I'm hoping that the appropriate government authorities, such as the Chicago Department of Transportation, as well as the Chicago Police Department, make some data-driven policy changes. Like I mentioned, I'm working with 5 data sets. Their sizes are all over the place. As you can see, one has 206 rows and others have roughly 500,000 to over 1,000,000 rows. In the top right corner, I am plotting a graph which shows you the location of the speed cameras as well as the crashes. The blue dots represent the speed cameras and the red dots represent crashes. I will say I'm only plotting 10,000 crashes, whereas the dataset contains a whole lot more. So yeah, there's a lot of crashes that take place in the city of Chicago. In the bottom right corner, I am plotting a distribution of crashes in relation to their proximity to the speed cameras. So closer you are to the speed cameras, the crash rate is significantly low, but the further and further you get away from the speed cameras, the number of crashes go up pretty high. I am conducting 4 separate t-tests because in my opinion the crash rate or crash safety problem is a multidimensional problem. You cannot just rely on one variable. Crashes tell us about the frequency, whereas whether those crashes ended up being fatal or they were, injuries tell us how severe they were. I'm also including violations so that I can include driver behavior in this analysis. As such, I ran multiple models to study how, like I mentioned, individual factors such as fatalities, injuries, and violations contribute to the crash frequency, and I was able to conclude that crashes are substantially lower in areas where speed cameras are enforced versus where they're not. I could have used logistic regression, but the goal of my analysis was to determine whether or not speed cameras reduce the frequency of car crashes. Since I'm working with frequency, which is a continuous variable, as opposed to how severe a car crash was, whether it was fatal or not, which is a categorical variable, I ended up going down the linear regression route as opposed to logistic regression, because logistic regression helps us predict categorical variables, whereas linear regression helps us predict continuous variables. So, in summary, why should you care about this analysis in the first place? Well, because in the year 2024, as I mentioned in the lightning presentations, the number of car crashes that took place were 112,000. The number of injuries that took place were 25,000, with the number of fatalities being 124. That is roughly 4 times our class size, so the number of fatalities is not low, it's pretty high. How am I doing this? The data that I got was publicly available, and I would 100% recommend every one of you to go through the data set because the data contains a lot of interesting fields. It contains information on the vehicle type, make, model, description, the year, whether or not there were any passengers in the car, how many people are involved in the car crash, all kinds of information. I was able to incorporate hypothesis testing, conduct various different statistical tests, as well as create a whole lot of linear regression models, things that I learned in this class. And as a result, I'm hoping that the appropriate government authorities make some data-driven policy changes. Since this data is publicly available, it makes sense for this report to be publicly available as well. And since the data constantly keeps changing and evolving, this report, as a result of new data coming in, also changes. So that's my presentation. Thank you.